So this is a problem of pipeline. This is a problem of for BPUT exam pipeline on the topic pipelining. So question is what? A 4-stage pipeline has stage delay as 150, 120, 160 and 140 nanosecond. Registers are used between stages and have a delay of 5 nanosecond each. Calculate the total time taken to process 1000 data items on this pipeline, or you can say 1000 instruction on this pipeline, and also calculate the frequency required to each clock pulse. Assume that constant clock rate is there. Assume that this is the constant clock rate is there. So question is what? How many stages is there? 4 stages. 4 stage pipeline has delay 150, 120, 160 and 140 nanoseconds. Delay means the execution of phase duration time or phase execution time. Okay. So have a solution. So have the diagram. So how many stages are there? 4 stages are there. How many stages are there? 4 stages. Stage 1, stage 2, stage 3, stage 4. So for 4 stages. So first stage delay is what? 150, or this is called what? Phase duration of S1, second phase duration, third phase duration, fourth phase duration. 150 nanosecond, 120 nanosecond, 160 nanosecond, and this is what? 140 nanoseconds. And these are the corresponding registers. For interface register, you can say corresponding latches are there, which is given in your question. What registers are used to between stages? So you can draw this R1 to here, R2 here, R3 here and R4 here, no problem. I just place here R1. Okay, so here R1 and R2 and R3 and R4. So, and also in question given is what? Stages have a delay of 5 nanosecond, means each stage having a delay of 5 nanosecond. So so what is the maximum phase duration? Maximum phase duration is what? Maximum phase duration is what? 160, not 150, 120, 160, 140. So which duration we will take? I told you maximum phase duration. So that is what? 160 na? This is what? 160. Why? Because if I will take 150 as a phase duration, and then when an instruction is loaded to this pipeline process, so 150 is the maximum phase duration. So in 150 nanosecond he will stage 1 will complete his task, where S2 will complete his task within 120 nanosecond. But 160, when come to stage 3, 160 nanosecond is required to complete this S3 phase, or you can say stage 3. But we have the maximum time is what? 150. So it is not possible to execute the stage 3. That's why I told you the maximum phase duration would be taken as a phase duration of a pipeline. Phase duration of a pipeline. So first we have to calculate what? Total time take to process 1000 data. So look, so as per maximum stage, we have to calculate first what? Maximum stage delay. So how we can calculate the stage delay? There is a formula. I told you. What is the formula? Stage duration plus less delay. What? Stage duration plus less delay. So stage duration, maximum stage duration is what? 160, and less delay is what? 5 seconds. Each less delay is what? 5 seconds. This is the latch of stage 3. So this is the latch of stage 3, and this is the latch of stage 2, and this is the latch of stage 1. So maximum stage duration is what? 160. That's why it is called what? Total phase duration. So maximum stage delay, or you can say total phase delay, is what? Stage duration, maximum stage duration plus stage delay. That is what? 165 nanosecond. 165 nanosecond. Okay. So next, in question he is asking what? Calculate the frequency required to each clock pulse. So already we know frequency equal to 1 by time, or you can say 1 by tau, equal to tau is what? Maximum total phase duration, or total maximum phase delay, or maximum stage duration, 1 by 65 for each clock pulse. Okay, so this is what? Frequency. So next come to calculate the total time taken to process 1000 data items. So we know pipeline execution type equal to k plus n minus 1 into tn. So k is what? K is what? K is what? Number of phases, and or you can say number of stages. Stage, number of phase, and n is what? Number of instructions or number of data minus 1, and tn is what? You can write tn or you can write tau, no problem. Okay, so total time required to execute 1000 data equal to k plus n minus 1 into tn. So k is what? How many phases here? 4 phases here. So k is what? 4. And how many data are there? 1000 data is there. So 1000 minus 1 into time. How many maximum time is required, or maximum stage delay is what? 165. So that is what? 165. So for 1000 minus 1 equal to 999. 4 plus 999 is 1003 into 165. Total equal to 16549.5 nanoseconds. So how many time it is required? Total how many time duration it is required to complete the task? Now 16549.5 nanosecond is required to time is required to complete the total 1000 data items.